Now I'm gonna talk about describing location in a distribution. So you're gonna hear the phrase percentile. This definition down here, the pth percentile. Pth percentile is, and kind of somehow get rid of that, the value in a distribution where p% of the observations are less than or equal to that value. One of the things you may see is this cumulative frequency graph, an ogive graph. What it does is it allows you to track a distribution and count. So let me kind of show you what it is here. It appears there's about 130 students in this ogive. Reason being, this graph ends right here on the right side. I trace my finger back over. It's about halfway between 120 and 140. That means that there are probably about 130 students in this distribution. Okay, so the next thing now, we can actually read this ogive. So for example, if I come down here and I look right here at the far left, I see that 10-year-olds are my youngest people on this graph. And they represent roughly 5 people because that's about a quarter of the way up. If I want to go next to my 11-year-olds, I come here to 11 on the X, I trace my finger up, I drag it over here, and I'm going to say it's about 15. That doesn't mean there are 15 11-year-olds. That means that there are 15 people who are 11 or younger. Since we know that from before there were 5 people who were 10 years old, 15 minus 5 is 10. We know there are roughly 10 11-year-olds in this distribution. And we can keep going through the whole process of reading this. So again, if I wanted to read along the x-axis, I could figure things out. So for example, going to a 16-year-old, if I trace my finger over, 120. So that tells me that there are 120 people who are 16 years old or younger. And the way that that would turn into a percentile is you would take 120 divided by the 130, which is the total number of people, and that would put it at the 92nd percentile, roughly the 92nd percentile. So someone who is 16 years old would be in the 92nd percentile. They are older than or the same age as 92% of the people in this distribution. Now you can also read it the opposite direction. What I mean is you can read the vertical. So for example, if I wanted to find the median is the 50th percent, 50%. Where's the 50th percentile? In this case, 65th person, half of 130 would be my median. So I'd go to the y-axis, I'd look for 65 right along here, trace my finger and drag it down to the horizontal, and I see that a 13-year-old. The 65th student is roughly a 13-year-old, so my median would be someone who is 13 years old. I could find the IQR as well if I wanted to, and I'll let you to trace that through and ask me if you have any questions on that. But again, you find the 25th percentile, you find the 75th percentile, subtract those two, and you could figure out your IQR. Another way to describe locations in a distribution is a z-score. It does not have to be normal to be a z-score. You can use a z-score on any distribution at all. The way you interpret it is you say the data value is blank standard deviations above if it's positive, below if it's negative, the mean. So Mr. Oliver has an AP Stats student with a mean height of 66 inches and a standard deviation of 4 inches. A student with a height of 60 inches would have a z-score of 60, that's my score, minus 66, which is my mean, that gives me -6, divide by 4, which is my standard deviation. -6 divided by 4 is -1.5. This student is 1.5 standard deviations below the mean. Transforming data. We'll touch on transforming data. The way you transform data is adding constants, subtracting constants, multiplying by constants, dividing by constants. So this would be if you were converting from inches to centimeters, if you were going from, inches to feet, if you were going from pounds to kilograms, Celsius to Fahrenheit, all these sorts of things. That's our transforming of data. When we add or subtract, we only add or subtract to measures of center or location. So what I mean is, if all of a sudden I measured everybody's height in inches and I found out that my measuring tape was off by an inch, I would go ahead and I would say, oh, I need to add an inch to everybody's height. I can go ahead and do that. So if I have the mean of a distribution and I'm going to add or subtract a constant, I just add or subtract that constant to the mean. Same thing holds for median, quartiles, and percentiles. But it does nothing to spread. Spread stays the same. So your standard deviations and your IQRs and ranges stay the same when you add or subtract a constant. When you're dealing with multiplying and dividing, you actually multiply and divide everything. Center, location, spread, all gets that number multiplied or divided. And in both cases, it does nothing to shape.